Okay, so have you ever like found yourself stuck in a line somewhere and you're just like, ugh, why is this taking so long?
It's funny you should say that because today's deep dive, we're going to give you kind of a superpower.
Oh,
Yeah. The ability to understand those cues using something called Little's Law.
Little's Law. Okay. I like the sound of a superpower, but
And it's not just about lines at the grocery store. This is like this universal truth
okay.
about how things flow in any system.
Yeah.
I mean, this applies to everything from restaurants to hospitals, even down to like how long that bottle of wine has been sitting on your shelf.
Really? Okay, so it's like that widely applicable.
Exactly, yeah. It's a really simple idea at its core, though.
Yeah.
It's just saying that there's a connection between how many things are in a system, how often new things are entering that system, and then how long those things stick around on average.
Okay, I think I'm with you so far.
And the really amazing thing is this really simple idea. Little's Law can help us make sense of things that seem really, really complex.
Okay, I need an example. What about that wine bottle on my shelf? What's going on there?
Okay, so imagine you're a wine collector,
Ah.
and no judgment if it's just the one bottle for now.
Yeah, it's a small collection at this point.
So let's say you buy, on average, 2 new bottles of wine each month.
Okay.
That's your arrival rate.
2 bottles a month, arrival rate. Got it.
And let's say you usually have about 12 bottles in your collection.
Okay.
That's the average number of bottles in the system, which is like your wine rack in this case.
Okay. All right, I'm following. So 2 bottles a month coming in, 12 hanging out in the rack.
Exactly. Now, Little's Law tells us we can actually figure out the average time a bottle stays in your collection. We just divide the number of bottles in your collection, 12, by the rate at which you buy new bottles, 2 per month. What do you get?
Okay, so 12 bottles divided by 2 bottles per month. That's six.
Yeah,
Six.
exactly.
6 months.
6 months. That means on average, each bottle of wine spends about 6 months in your collection before you drink it.
Wow. Okay, I never thought about it that way. It makes total sense when you put it like that, but that's really cool. And it was so easy to calculate. I could do that.
Exactly. And that's the beauty of Little's Law. It gives us this really simple way to understand the relationship between these key factors. How many things are in the system, how fast new things are entering, and then how long things are sticking around. And we can apply this to all sorts of things.
So just to be sure I've got this, because it's not just about wine, right? We could use this in all kinds of situations.
Absolutely. Think about like a busy coffee shop,
Okay.
and you're the manager. You're trying to figure out if you need to hire more baristas to speed up the line because people are waiting too long.
I'm seeing where you're going with this. Okay.
So you notice that on average, there are always about 10 customers, either waiting in line or they're at the counter getting their drinks.
Yeah.
So that's your average number of customers in the system.
Okay, so 10 customers in the system.
Exactly. And during rush hour, you serve about 30 customers every hour. So that's your throughput rate. How many customers are actually moving through the system per unit of time in this case?
Okay, so 30 customers an hour is the throughput rate. That's a lot of coffee.
It is a lot of coffee.
Mm.
Now, with Little's Law, we can actually figure out the average time a customer spends in your coffee shop from the moment they walk in, get in line, to the moment they leave with their latte in hand.
Okay, I think I can do this. Let me try. So we divide the number of customers in the system, that's 10 by the throughput rate, 30 customers an hour. So that's 10 divided by 30, which is 0.33. 0.33.
You got it. But yeah, 0.33 hours, it sounds a little clunky. Let's convert that to minutes.
Okay, so how many minutes are in an hour?
60. So 0.3 times 60
Yes.
is about 20 minutes.
Yes.
So each customer is spending an average 20 minutes in the coffee shop.
Exactly. Now,
Yeah.
you as a coffee shop owner have this crucial piece of information. You know that, on average, customers are waiting around for 20 minutes. So now I can decide, is that too long? Should I maybe hire an extra set of hands to try to get that number down?
Exactly. And the best part is that this same logic applies to all sorts of other situations.
Like what? Give me another example.
Okay, well, let's say you're in charge of a factory.
Okay, a factory. Now we're really getting into it.
But that's the beauty of Little's Law. It can handle it. So imagine you're responsible for making sure that, those cool new phones
Mm-hmm.
get made on time.
Yep.
Thousands of phones going through the production line every day.
And time is money, right? Especially in the tech world.
Absolutely, yeah. Every minute a phone spends in the factory, that's adding to the cost. So let's say you notice there are always about 5,000 phones, in various stages of production,
Mm-hmm.
being assembled, tested, packaged, the whole works. That's your average work in progress, the stuff that's in the system.
5,000 phones. That's a lot of work in progress.
That's a lot of phones. But let's say your factory, it's cranking them out. It's churning out 2,000 finished phones every day. That's your throughput. Kind of like those coffee shop customers, but, fancy circuits instead of caffeine.
Right, right. So 2,000 phones per day is the throughput. Okay, I think I know what's coming next. Little's lot time.
Exactly. We can use it to figure out the average time it takes for a single phone to go from parts to a shiny new gadget in a box ready to ship.
All right, hit me with the numbers. So we divide the work in progress, 5,000 phones, by the throughput, 2,000 phones per day. 5,000 divided by 2,000 is 2.5.
2.5.
2.5 days.
Exactly. On average, it takes 2.5 days for a phone to move through your entire production process. Now you, as the factory manager, you can use this knowledge to make some pretty important decisions.
Yeah, because if I wanted to speed up production, I would need to figure out a way to either reduce that work in progress number or increase the throughput. Right.
Exactly. So maybe you find a way to streamline the assembly process. Maybe you invest in some new equipment that can test multiple phones simultaneously.
So Little's Law isn't just showing you a problem, it's helping you to actually come up with solutions.
Exactly, and helping you ask the right questions. So let's take this a step further. Imagine you're not just managing one factory. Imagine you're managing a whole network of warehouses and distribution centers.
Okay, so we're going global now.
We're going global.
Yeah.
So suddenly, you're not just concerned with how long it takes to make a phone, but how long it takes to get that phone from the factory to a... Absolutely. Think about all those packages zipping around the world.
Yeah.
Let's say your logistics company handles, on average, 10,000 packages per day.
Oh.
That's your arrival rate.
10,000 packages per day.
And let's say there are always, on average, about 50,000 packages in transit at any given time, making their way from warehouses to trucks to airplanes to delivery vans.
Wow.
That's your average number of packages in the system.
Okay, so 10,000 packages per day arriving, 50,000 in transit anytime. I can see where we're going with this.
Using Little's Law, we can figure out the average time a package spends in transit. We divide the number of packages in the system, 50,000, by the arrival rate, 10,000 packages per day. What do we get?
Okay, so 50,000 divided by 10,000, that's 5. It takes an average of 5 days for a package to get from point A to point B.
Precisely. And now you, as this logistics mastermind, you have this valuable piece of information. You can use this average transit time to set realistic delivery expectations for your customers.
Yeah.
You can even start to identify bottlenecks in your system.
Like if packages are getting stuck at a certain sorting facility or if there are delays in a particular shipping lane.
Exactly. So Little's Law can help you pinpoint these areas where things are slowing down so you can make improvements and get those packages moving more efficiently.
This is blowing my mind. We started with a single bottle of wine, and now we're optimizing global logistics.
And the best part is we've only just scratched the surface.
Wait, there's more.
Oh, yeah. Little's Law, it isn't just for these physical things like phones and packages. It can even be applied to the digital world, like managing your inbox.
Okay, you've officially convinced me Little's Law is, like, insanely useful. I'm sold.
Yeah, but remember, it's not about, like, memorizing a formula, right? It's about understanding the core concept.
Right.
Which you totally get.
So there's this connection between, like we've been saying, how much is in a system, how fast it enters, and then how long it stays there.
And that connection, it's everywhere.
Okay.
Which brings us to something I think we could all relate to. Email.
Oh, no, not my inbox. Don't even go there. It's like a black hole.
Oh, we're going there.
Yeah.
Don't worry. Little's Law can help. So let's say you get, I don't know, on average about 100 emails per day.
Yeah, that sounds about right, unfortunately.
And let's say you usually have, about 500 unread emails just sitting in your inbox.
Okay, first of all, no judgment.
None at all. We've all been there.
I'm getting to them.
Yeah.
Eventually.
See, but now we can actually calculate how long, on average, an email sits in your inbox before you read it.
Oh, gosh. Okay. All right, so let me try this. So we divide the number of emails in the system, so that's 500 unread, by the arrival rate, which is 100 emails per day. So 500 divided by 100, is that 5 days?
5 days, you got it.
Oh, my goodness.
So on average, each email is languishing in your inbox for 5 days before you even open it.
Which explains why sometimes people will reply a week later and be like, oh, just seeing this.
Exactly. But now that you know this, You can actually start managing your inbox more proactively, thanks to Little's Law.
Oh, okay. So I could set a goal to like respond to emails within, say, 2 days on average.
Exactly.
And then to reach that goal, I might need to like figure out ways to either, like you said, reduce the number of emails that are coming in or increase how quickly I can get through them.
Yes.
This is actually kind of empowering. I feel like I have more control over my inbox now.
That's the whole point. It's not about the numbers themselves. It's what those numbers are telling you and how you can use that to make better decisions.
So whether we're talking about wine bottles or phones or shipping containers or even just emails, Little's Law gives us this amazing framework for understanding how things flow.
Yeah, and once you start seeing the world through the lens of Little's Law, you start to notice these patterns everywhere, and it's kind of amazing.
It's like this secret code for optimizing, well, pretty much everything.
Exactly. And the more you use it, the better you'll become at spotting those bottlenecks, those areas where things are slowing down. And then you can figure out, okay, how do we make this more efficient?
This has been such an eye-opening deep dive. I feel like I've learned a whole new way of looking at the world, and it's all thanks to this one surprisingly simple law.
And that, my friend, is the power of a fundamental principle. It can unlock these really cool insights in the most unexpected places.
Totally. So the next time you're stuck in a traffic jam or waiting in a really long line, or yes, even battling your inbox, remember Little's Law.
It might just help you find a better way.
Thanks for joining us on this incredible journey into the world of Little's Law. Until next time, keep those cues moving and those insights flowing.